in Chennai and Chandigarh University. He also plays a pivotal role in the shaping the academic and research landscape at IIT Raipur, serving on multiple department and institutional level committees ranging from curriculum design to national event coordination. Today he joins us to share his expertise on introduction to quantum programming, and we are certain that his insights will greatly enrich our understanding and spark new directions for academic and research pursuits. Please join me in warmly welcoming Dr. Kapil Kumar Soni, sir. Thank you.
Thank you, sir. And I request Dr. T. Sudharani ma'am, HOD of CSE department, to welcome Dr. Soni, sir. Now, I would like to hand over the session to Dr. Soni, sir.
Thanks so much for coming.
That is mine, sir. I'm just giving my thanks, but now let's proceed.
So I don't know anything about this. I'm going to learn from you.
Okay. So it's an honorable moment for me also to just take this expert session for you all people. So at the outset, I would let you know that being a researcher as well as a practitioner in the domain of quantum computing and algorithm, this is my moral responsibility to make you all comfortable while learning these all topics what we will be covering in the mic. So my voice, I think.
Your voice is audible, but mine may not be clear, sir.
It's that it is fine. So just be comfortable here. Just take your time and. It's okay. So let's proceed with our first session that is devoted to introduction to quantum programming. So as far as I am known that your FDP started from 10th of this month. So already you people have done for the last 3 days. And I'm expecting you people have already done with the fundamentals or the requisites which are priorly required in order to proceed with the programming perspectives. Okay. But before proceeding to that one, I'm just asking whether have you done any practice related to the programming concepts earlier in the sessions? This is from this session onwards, so just because of from the ground up I will be covering everything. Okay. So just try to just proceed with the flow of this lecture session. I'm just going to proceed. Just please next slide. Which one? This? Okay. So now these are the outlines of our session first. So we will start with the introduction to quantum programming. Okay. Why we are just looking for the quantum programming and what is the need to program a quantum computer. And we need to understand the thing is also that whether we people are going to program a quantum simulator or we are going to program a real or dedicated quantum computer. But I will demonstrate both of them in the today's sessions, so that you people will be comfortable while doing or while coding your programs using Qiskit based programming language. That is one of the programming framework which has been proposed by IBM. Okay, so it's one of the known popular programming framework, but I do not say like, and I am not a promoter to IBM also, so I do not say that this is only the framework through which you may realize your quantum programs. You have a number of options, I will let you know also, but one of the popular that is quantum programming framework we have, so we will look into it. Now the significance of the IBM Qiskit framework we will be covering, followed to that one the key features, okay, because without knowing the programming features, that would again be not a good thing to proceed with the programming perspectives. Okay. Now next to that one we will start with the installation of a Qiskit, okay, like in your local machine. I will demonstrate you 4 or 5 different ways through which you people may realize your programs, okay, or you may be able to execute your programs. You may execute your programs on your local machine, as well as you can execute your program on the local server, okay. You may execute your program on the cloud environment, okay, as far getting the platform independencies. You may be able to execute your quantum programs on a dedicated quantum computer machine, okay. So all of these aspects we will be covering, okay, in our that is point number 4. After that one, these different codes executions we will be looking for, and the realization of some quantum codes what you people have already learned in the last 3 days, because as I am known that what you people have been learning in the last 3 days, so I would try to cover whatever the things you people have learned out, and we will be able to demonstrate these all things in our sessions, okay. Now follow to that one, few of the quantum algorithms we will also be looking for, like Grover's algorithm is our today's scheduled lecture, like quantum phase estimation is again one of the scheduled lecture, okay. So we will have we will have a look over that how to code these algorithms using a quantum programming Qiskit, okay. Followed to that one, we will have a concluding remarks, okay. So now let's start with our journey here, that is what about a quantum, okay. You try to understand, as I am just again assuming that you people are known about the fundamentals, only starting from the computer science perspective, okay. Just try to understand what I am interested in. Quantum machine, okay, or the quantum computer, they are basically designed to realize exponential number of operations in just a single step of execution, okay. This is the simple thing that is to be understood. So what does it mean if I say that I have one of the dedicated machine, and that machine is giving us the privilege to realize exponential number of operations in just a single step of execution? So would it be a possibility of that is to achieve a computational speed up or not? Yes, definitely, because if suppose you have exponential number of operations, so in order to execute these all operations on our classical machines, we require at least the same amount of time in order to execute each instruction, clear. But instead, if we execute the same code or the equivalent quantum code on the quantum machine, that would be completed in just a single step of execution, okay. So if it is taking a 2 raised to the power n number of time, and the same task, if I am calling that it is completing in order of 1 time, like in a computer science domain, okay. So we people are here expecting some computational speed ups, and this is that is all what we computer science people are belong to, okay. Because in our machines, like in a classical machine, do we have any intrinsic parallelization facility? our classical machines like our laptops, desktops, even workstations, these machines are not intrinsically parallel. Okay, they are not giving us the facility to parallelize a task independently, clear? But here in a quantum machine, this machine is giving us the privilege to realize our operation in an exponential number of ways. Okay, but how? Just to realize some quantum mechanical phenomena, clear? And one of the famous phenomena is known as superposition. Okay, so I will let you know step by step that why we people are looking for. I am just recalling the thing, that is the first thing, like in a classical processing purpose, because the machines are not parallel. Do you agree or not? Machines are not parallel. So, but what the computer architects have already been proposed to include the parallelism in our classical machines. The people have proposed already. Like, let me remind you all, at the lowest level of processing we can have the pipelining. Yes or no? That is the multiple instructions to be executed simultaneously. That is at the lowest level of processing. Clear or not? That is the first level of parallelism what we could achieve through the architectural mechanism of the computer system. That is the first thing. Now come up. So when we come up, we have the privilege to realize our codes in a multi-threaded format. Yes or no? So the multi-thread based code we can execute, and the hyper-threading also is available at the back end. Now if we come up again, we have the multi-core based processing. Yes, multiple number of cores are available in order to parallelize our task. If we come up again, multi-processor based processing is again possible. If we come up again, we have multi-node based processing, that is used to be called as, again we are taking into in a connection of a local area networks. Okay, several nodes to be connected with some servers, clear? So but what we people are interested in, we were interested in to make the parallelization in a classical machines. But even though by incorporating these all different kinds of parallelism in our machines, we could not be able to achieve the intrinsic parallelism because the machine is not supporting. Okay, by introducing a phenomena of quantum computing called a superposition. Okay, superposition in a single word, you just try to understand, because I do not I do not have any interest that what you people have learned right now. You try to understand in a just precise manner. Okay, in a keyword based things, you try to understand that what is happening in the system and why we people are interested to just develop such a system. Clear? Now what does the mean of superposition? That is multiple states or the multiple quantum states can be realized in parallel. Okay, so the multiple quantum states which are being realized in parallel means, like if we talk about a single qubit, okay, because here in a quantum machine we have a qubit instead of a bit. Okay, so if we have a single qubit, there would be two different possibilities. Okay, like 0 and 1, but the 0 and 1 is not same as the 0 and 1 we people are processing with our machines. Okay, so first try to understand with the information what we people are going to deal with. Understand? Like in a classical machine, we used to deal with the scalar informations like 0, 1. 0 and 1, these are the mutually exclusive values. Either you are going to store 0, means it is understood that 1 is not present, and if you have stored 1, means there is no possibility of 0. This is the mutually exclusive behavior that is realized by what? A classical bit. But here we have not the scalar information. What we have here? That is a vector of information. Like instead of 0 and 1, we have cat 0, cat 1. Okay, and these cat 0 and cat 1 are just acting as the vectors of information. Clear? So this is the mathematical notation what we used to take, like cat 0 and cat 1. This is how we used to write. This is our cat 0, yes? Okay? So this is the mathematical notation to take for the cat 0, and what is the vector? The vector to be written as what? 1, 0. It is what? 2 cross 1 vector. Clear or not? Yes? Similarly for what? For the vector 1, we take what? 0, 1 of 2 cross of 1. So if we have a vector of information, then to make any transformation onto such vectors, we need some quantum operators. Yes or no? And to have such operators, the size of the operator should be at least compatible to proceed with what? With the vectors. Understood or not? Like if we have a vector of, suppose for a single bit, we have a vector of size 2 cross 1. So you have also learned some of the quantum gates. Yes? Like single qubit gates, poly matrices you must have learned. Yes? Like poly X, poly Y, poly Z. Yes? Hadamard you must have learned. Clear? What must be the size of their quantum operators? This is 2 cross 2. Yes? Why? Because the 2 cross 2 operator must be the size to deal with every vector which has already been explored over the 2 cross 1 dimensional Hilbert space. Understood or not? So if such a vector of information has already been explored, okay, so in order to make any transformations we need what? The same size, or the order of that matrix operator should be of 2 cross 2. Similarly, if we have suppose 2 qubit, okay, so for 2 qubits the operator size must be what? 2 raised to the power 2 cross 2 raised to the power 2, means it is just 4 cross 4. If you are going for 3 qubit system, so the operator size would be 8 cross 8, 4 qubit system 16 cross 16. So like in a way, if you have n qubit system, so the operator size must be what? 2 raised to the power n cross of 2 raised to the power n, and this must be clear anyways. Clear or not? Okay. So this operator would take your vector, it would transform your vector from one location or one position to the other position. Okay. So just for applying such a transformations we need some quantum matrix operations. Okay. So now before proceeding with other operations, because the operations, several operations are there and we will be discussing again. Okay. So many things will be revised also in programming concepts, and we will be able to just execute these all things on our machines. Clear? So the thing is that the quantum programming, what we are looking here, like the people will come to us with some problem. Okay. Like the problem means what you try to understand. If a certain problem comes to us, okay, so we people do not say that a quantum machine or the quantum computer are the replacement to the classical computer. We do not say like. Okay. What we are talking about, that when a particular problem comes, okay, it should be initially submitted to the classical computer. If the classical computer, okay, like our laptops, workstation, whatever we have, okay, enough powerful machines, whatever we have, if such a machine is enough capable, okay, or enough efficient in order to solve that problem, then that problem would be definitely solved by the classical machine. There is no need of quantum. Clear or not? There is no need of quantum. Like just a recent war we had with Pakistan. Yes or no? If it is only working with the drones, so why to send the missiles? Yes or no? So that is only the thing, that if the classical machine is enough capable to process any particular problem efficiently, okay, so it should be solved by the classical machine. But if in any case the machine incapabilities are available, then only the same problem would be sent to the quantum machine. Okay, this is like one of the mapping is there, like you must have learned in a vector and a scalar processing system. Like initially the task comes to a scalar processor, yes or no? If the vector processing is needed, then that task would be handed over to the vector processor. Once the vector processor completes its task, the results would be again sent back to a scalar processor, and from the scalar processor we will obtain the results, yes or no? So the similar architecture we people are assuming here, that the task should come to the classical machine, clear? If the machine is capable, it would process automatically. If the machine is not capable, it sends the same task to the quantum machine. Now the quantum machine will solve that task, but you know that the outcome of the quantum would be what? Again classical. So this is the mapping here, because once the task is switched over to the quantum machine, the quantum machine will process it in an efficient way, okay? After generating an speed up solution, the solution or the states, classical states would be sent back to the classical machine, and from the classical machine the end user can get the output. Understood or not? This is the simple transitions, okay, and these need to be maintained. So now try to understand, being a computer scientist or to belong to a computer science engineering domain, for every problem what solution we have? Algorithms, yes or no? For anything we try to identify the algorithms, means certain sequential steps, some order steps we people are expecting in order to solve a particular problems, clear or not? So if we are expecting a particular solutional steps in the form of algorithms, so the same quantum algorithms we people are expecting here in quantum methods, clear or not? But remember, because still this quantum machine is available in an early stages of development, I still do not say that we have enough potential of such a machines, clear or not? We are still in an era of early stages of development. So whatever the quantum algorithms you people are thinking about, for the same algorithms you will have to develop its equivalent quantum circuits. Are you getting my point? If you have certain solution, okay, if you have certain solution in your mind in the form of algorithm, so try to develop its equivalent quantum circuit. So once you have made a quantum circuit, that quantum circuit would be equivalent to that quantum algorithm. Like one of the famous hypotheses I am just recalling here in a computer science domain, like Church-Turing hypothesis. If you remember, what was the hypothesis? Church and Turing hypothesis. That is, the hypothesis was concluded as, that is, for every Turing machine, that is a mathematical model of computation, yes or no? So for every Turing machine we have the equivalent we have the equivalent algorithms, yes or no? And for every algorithm there must exist a Turing machine. This was the hypothesis only. What does it mean? It means simply that if we have an algorithm, means it is equivalent to the computational model, or if you have the computational model, it is equivalent to the algorithm, means anyways we have some solutions for a problem. Understood or not? Clear? So now the same thing here, that if we have the quantum algorithm for a solution, or we have the quantum circuit, so these both will be equivalent to each other. Understood? So if you are going to propose a quantum circuit, then that would be a considered solution, or if you are proposing a quantum algorithm, that would again be a considered solution. But what would be good enough if you produce both of them, okay? Because if you develop both of them, so it would impact a lot to just synthesize your solutions. Clear my point or not? Now let's proceed with one basic example, okay? because it just came to my mind. I am also dealing with that is investigating one of the project with ISRO on quantum memory development. So just making you all to just visualize what I am letting you know. Suppose we have a RAM. Yes, we have a RAM. Okay, random access memory. What should be the size of a RAM? Basically, we used to call it as, it has a combinational circuit of size, suppose 2 raised to the power n cross of m. Yes or no? Okay, there would be 2 raised to the power n number of address locations, and at each address location we used to store some words of information. A word size may be of a byte, 2 byte, 4 byte, 8 byte, 16 byte, anything. Clear my point? But if you talk about a RAM, I am calling again that there would be 2 raised to the power n number of addresses. Okay, so there must be from like all zeros, so suppose all ones, there would be 2 raised to the power n number of address locations. So classically, because the name implies, the name is what? The random access memory. Means randomly any of the address location can be accessed at a time. And this is still limited. Why? Because of the architectural constraint. Yes or no? If you remember the architecture again, there is a memory address register, there is a memory data register. Okay, so whatever the instruction we are going to fetch, the corresponding address is to be initially contained in the memory address register, and from that register we start pointing to an arbitrary address in order to fetch either the instruction or the data which is contained there itself in a RAM, but one at a time. Clear my point? One at a time. But now, instead of having such a classical RAM, if I say that I have a quantum RAM, and what I said as per the definition of a quantum RAM, what I said with the definition of a quantum computing, it should realize exponential number of operations in just a single step of execution. You try to connect here. If I am saying that exponential number of operations can be realized in parallel, means all such address locations which are contained in a RAM, they all are available or accessible in parallel. What does it mean? Like if you are opening a book, you try to understand. If you are opening a book and just turning down the pages, means all of the pages you have already gone through in just a single moment of time. This is just a RAM we are talking about. Clear or not? Because entire time we do not keep the book in our hand. Getting my point? Just try to correlate with the concept of a RAM. Clear my point? So what I am just talking about, that if all such address locations can be accessed in just a single step of execution, means entire RAM content is available for the quantum processor for the purpose of processing. Clear my point? Yes or no? And just remember this thing, I will reconnect these all things, whatever I am going to discuss, because there is a 2-day schedule and everything is planned. Whatever I am just discussing, I will correlate till the end of tomorrow's session. Clear? So just try to connect with them, all these things. Now another one of the example let me share with you. Like what a problem we used to call as a computationally hard. For a problem we do not have a polynomial time solution. Okay, at least an exponential complexity we have to spend. Yes or no? This is an asymptotic bounds, that at least an exponential complexities to be which are involved in order to have the solution of the problem. Clear? But for the same problem which is now computationally hard, if we seek the same solution here in a quantum, so can it be advantageous? Yes. Try to understand. Like a knapsack problem, you try to understand. Okay, knapsack problem. What is the knapsack problem? There are two categories. The first one is greedy approach. Okay. Second is dynamic programming. With the greedy approach, we have a polynomial time solution again. but it is based on the optimality. Clear or not? Still the optimality would be preferred here in a dynamic programming, but instead of a single specific solution, we will derive all the different possibilities. Clear or not? And what was the problem? We have to place the n number of objects, small n you may consider, n number of objects into the capacity of the knapsack such that the size of the knapsack should not be exceeded, as well as we should get the maximum profit. Yes or no? If this is not only the problem, that is to be just discussed like that, some weights are there that is to be placed into the capacity of knapsack. You try to correlate the thing. Still this knapsack problem is correlated with this RAM. N number of processes are there. Yes or no? And these n number of processes we need to accommodate. And we have a limited capacity of what? A knapsack. Yes or no? We have a limited capacity of this knapsack here. Clear my point? So what we people are dealing with? We are dealing here, that is, we want to accommodate maximum number of processes into the capacity of the knapsack such that the capacity should not be exceeded, as well as the thing is that the degree of multi-programming should also be maintained. Clear my point or not? So this is a single analogy what I am just sharing with you. Now try to understand. Like a knapsack has a greedy solution solvable in a polynomial time. Okay? But with the dynamic programming, where we explore all the possible paths, the complexity of the problem is exponential. Yes or no? For n number of objects, what is the complexity? What is the complexity? Order of 2 raised to the power of n, because from the root we explore all the possibilities. Yes or no? Okay? We explore all the possibilities. So if you are going to explore all the possibilities, like let's take one example of 3, like 3 objects to be placed. Okay, with 3, what should be the complexity? 2 raised to the power of 3. What does it mean? 2 raised to the power 3 means there are 2 raised to the power 3 means 8 different paths we have to traverse in order to obtain our optimal solutions. Clear my point? Okay. So in a classical machine, one path can be traversed at a time. Yes, from the root to the leaf. If the optimal solution is not found, backtrack. Okay, again from the root to leaf, again not optimal, no such optimal solution, again go back and till the end of the leaf. Clear my point? So because of such a thing, this complexity is involved. But if I say the same problem can be solved here in quantum, now try to understand. 2 raised to the power n possibilities. Okay, like 2 raised to the power 3, that is 8. All 8 possibilities can be explored in just a single step of execution. Clear my point or not? In just a single step of execution, you will be enough capable of getting your all possible optimal solutions. Understood? So your optimal solution would be possible in just a constant step of execution. But try to understand again another fact. Like a quantum machine is having a privilege that in a constant step of execution it can get anything. Okay. But in order to report our answer, okay, in order to report or to measure or to observe our answer, we should run our algorithm for some number of iterations. Okay. And like I am letting you know, here in a quantum the same problem can be solved with under root of 2 raised to the power of n. Okay. Somehow the computational speed ups are possible. Okay. Like it is a exponential complexity involved. So it's a quadratic exponential speed up what we people are expecting. Understood or not? Okay. So not only these 2-3 examples are available to us, n number of solutions or n number of solutions we people can realize in our mind. Like this FDP is devoted to quantum machine learning. Yes? Okay? Now let me share you one more. Like for every data set what we use to process, okay? The data set suffers with the problem of dimensionality. Yes or no? If we have exponential number of dimensions, okay, what irrespective of the size of the samples, okay, if the exponential number of dimensions or the features, if available in your data set, the processing of your model or the training of your model will again be time consuming. Understood or not? Clear? So there should be an efficient mechanism through which we should process such a, or we should deal with such a dimensionality reduction mechanism in an efficient manner. Understood or not? Like one of the best known algorithm for the dimensionality reduction, that is dimensionality reduction is basically a solution. Clear? The problem is a curse of dimensionality, that is dealing with every data set. Clear? So now for a dimensionality reduction we have a standardized algorithm named as principal component analysis. What is the complexity involved in the PCA? Order of n square in best case, that is the computation of covariance matrix. Yes or no? That is entire complexity of that algorithm depends on the computation of covariance matrix. But in a worst case, the same complexity can lead to what? Order of n cube. Clear my point or not? But if I say for n, like for cubic polynomial complexity, we have no such concerns. Yes or no? Because still the complexity is polynomial. Why to be concerned more? But the concern is what? When our dimension is exponentially increasing or the dimensions are exponentially scaling. Understood? So in such a manner, our polynomial or cubic polynomial complexity problem is now becoming as exponential cubic problem. Clear my point or not? So now for such a problem still we are looking for some efficient solutions. Clear or not? So now you try to understand, if we have, like in a particular data set, if we have suppose 128 dimensions, or let's go for image processing. Yesterday you had one session related to image processing. Like we have a small amount, let me take otherwise, 64 cross 64 size of pixel images. Yes or no? 64 cross 64. So if 2 raised to the power 6 multiplied by 2 raised to the power 6 again, okay, these many number of pixels to be processed. Clear my point? But if it is there any efficient mechanism through which we can process all of them in parallel, yes, there is a possibility. For 6 features or for 6 cross 6, like 64 cross 64, only take what? 6 and 6, that is 12 number of qubits, and with the 12 number of qubits you can be able to expand your entire image in just a single step of execution. Yes or no? Means you will be able to visualize your image. Getting my point or not? So the things which are dealing with the quantum, are nowadays practical. Okay, if we talk about like 15, 16 also, like 2015, 16, 17, 18, till up to that time also, there was no such realistic scenarios what we had. Clear or not? Everything was not available. Right now enough number of resources are available for the quantum computing development, and even our India is really participating in an exceptional manner with a 6,000 crore rupees of re-initiated funding, okay, for the development of the quantum machine. If you know, there are 4 different verticals the people have planned. like for quantum computing and algorithm, quantum communication and networking, yes or no, quantum sensing and metrology, quantum materials and devices. These four verticals are collectively taking in order to have the dedicated development of the quantum machine. Understood or not? Okay. So now just try to realize some significance of the quantum computing, then we are going to proceed. Okay. अच्छा मैं आगे आ गया क्या पहली? Let's. It's okay. But most of the thing I have already covered. No need to be worried. Now come on to the programming aspect again. That is the quantum mechanical principles. Okay. That should be realized by our quantum programs. So what we are intended here, that whatever the quantum principles you people have learned till yesterday, okay, now it's the time to realize these all principles practically. Understood or not? And I am not talking about the practical realization of these principles on your local machine. I am talking about what? To execute these all things on the dedicated IBM's quantum computer. Clear? So you go for that is programming a quantum computer. Clear my point? Now, so for algorithmic realization, because I told you for everything we have what? Solution. Solution in the form of algorithms. Here the quantum algorithm is equivalent to quantum circuit. So either you are proposing a quantum circuit or you are proposing a quantum algorithm, both are equivalent to each other. This is just a simple analogy as per the Church-Turing hypothesis, what we discussed. Clear my point or not? So whatever the solution you have, try to come up with both of them, algorithm along with the circuit, because the circuit based execution would be there at the machine. Clear? For every algorithm, whatever we write, we have to construct its equivalent circuit. Clear? Like in a pseudocode form also, if you propose an algorithm, it will go. If a conference paper you are writing like, okay, so such a form of the algorithm would also be acceptable. But if you are going for esteemed or very renowned SCIE or suppose like Scopus or dedicated quantum computing journal, it would not be accepted. Clear my point or not? Okay. So it is good always to look for your solution in the form of quantum circuits. Understood or not? If I say that quantum entanglement exists, yes or no? You know entanglement exists. What does the mean of entanglement? Now come up again. That is qubit correlation. The qubits are correlated with each other. But if we know that, okay, this qubit correlation is possible, how far the quantum particles are available? Okay, we are not bothering upon that one, because once we made them entangled with each other, okay, at any distance that entanglement would be carried out. Understood or not? So, but how do we realize such an entanglement through a circuit? Can you remember? A circuit of entanglement. How do we get the superposition? A simple thing, if suppose like this is my qubit, okay, the 0 I am writing in the form of theory of computation, okay, this is a notation I am using here with the basis of computational theory, okay. So this is 0 index qubit. So if this Q0 to be passed with what? With one dedicated gate to be called as Hadamard gate. Yes or no? So once you pass your qubit to a Hadamard, that turns your quantum bit into what? A superposition of quantum states. What do we call? Quantum states. Okay. Achha, I did not initialize anything here. What should be the default initialization? Because we people are learning programming. Okay. Like we used to maintain the counters. Counters means they are the variables basically. They are the variables when we write a loop or iterative program. Okay. So in any iterative program, we initially take the counters. Okay, that would take the count, like I initialize to 0, and it is going for less than or equal to, suppose, value n. Every time I is incremented with some value, not 1 always, because the updation of the counter would be anything. Clear? It would be an exponential, it would be an incremental, it would be a multiplication, it would be a division also. Okay. So now the thing is that, like a counter initialization, the qubit should also be initialized always. So what should be the default initialization of a qubit in the programming perspective? 0. Okay. So means your qubit is always there in a 0 state. Okay. But on the 0 state, if you are applying the Hadamard gate, it is turning down your 0 state into what? That is, this is initialized qubit 0, clear? We have passed the 0 to Hadamard. So now this qubit has been transformed to what? The superposition of quantum states. How many quantum states are available for a 1 qubit? 2, like 0 and 1. So when you pass this Hadamard here, your qubit state would be what? 0 plus 1 by root 2. Yes or no? We usually write it as to be root 2. What is 1 by root 2 here? This is all required. These all things are important to remember, because our tomorrow's session is dedicated to machine learning. To try to understand and to deal with any machine learning model, because what I told you just before, task should come to classical. If it is not efficient, then it is to be handed over to quantum. So once your task is decided that it cannot be efficiently done by the classical machine, then only that should be handed over to the quantum machine. But once we hand over the task to the quantum machine does not understand mutually exclusive 0, 1. Yes or no? It understands what? Cat 0, cat 1. It has no information about 0, 1. It has the information about cat 0, cat 1, means the vector of information. Clear? So we have to apply some encoding mechanisms. What to do? Encoding mechanism. Whatever the classical data we have, the same classical data to be encoded first into the quantum states. Understood or not? So just remember these all things. I will connect you tomorrow also. Okay. But before that one, you just let me know what is 1 by root 2 here. It's probability or probability amplitude. Just do not be confused. It is a probability amplitude. Okay. So probability amplitude. Okay. So why we people are concerned with the probability or amplitude always, you try to understand this fact also. There is an expansion of a qubit over a Hilbert space. So what is the Hilbert space? A complex vector space. Okay. So a complex vector space that is allowing us to measure our qubit information either in terms of length, what I am repeating again, to measure our information in terms of length and in terms of angle. Length means, for any vector, length means here an amplitude we are talking about. Clear? And for angle we are talking about what? Phase. Understood or not? So either the phase related information we can obtain or the amplitude related information we can obtain. So like this 1 by root 2, this 1 by root 2 is specifically here a probability amplitude that is associated with 0 and it is associated with 1. Okay? Like you know, because the fundamentals have already been done, every quantum particle follows what? Wave-like nature. Are yes or no? A quantum particle start means it starts like a waveform. Clear or not? So if a wave-like nature is followed by any quantum particle, so at different moment of time, the particle may be anywhere, yes or no, and with the different amplitudes. Clear my point? I will show you. I will show you these amplitudes. If you see here, this is the block sphere. This is the IBM Qiskit code. If you see, you just observe this movement of the vector. Okay, first you try to understand. Initially, it resets to 0. You just observe first. It resets to 0 first. Yes? Means this is the initialized condition of any qubit. Clear? Now, when it reaches to 0, I am putting that Hadamard gate on a single qubit. Clear? So, once I put that Hadamard gate on a single qubit, it immediately, like from this place, it immediately turned down to X basis. You just observe, when it comes here, immediately it comes here. Yes or no? And when it comes here, this inner circular basis will be rotated by the vector. Can you be able to observe? Huh? Yes. This is basically a superposition. Understood or not? I don't know whether the block sphere, the model have been discussed earlier or not. Just please do let me know whether discussed or not. Huh?
I think discussed, but we are showing it visually. I think that must be very.
It's okay, no problem. You try to understand. Everything, the analogies are always important. Okay. If you assume this sphere like a earth, earth is a globe. Okay. For earth we have a globe. It's also a 3D sphere. Yes or no? And over that sphere, okay, we have n number of dedicated points. Like similarly we have here n number of dedicated points for a quantum bit. Understood or not? Now this quantum bit is rotating only for this circular sphere. There are several bases. Yes or no? Like this is what? Where 0 and 1 is located. This is called to be a Z basis. Yes or no? And Z basis is known as computational basis. Understand? If you have not covered, so you please note down. This Z, this is called as what? This is Z basis. Okay? And over Z basis, at the top spin we have what? Cat 0. At the bottom spin we have what? That is spin up, spin down. This is the two mechanism of what? Electrons. Yes or no? Electron may be there in a up spin state, down spin state, or a superposition of both of them. Clear my point or not? So the thing is that if you are taking this block sphere into your consideration, okay, so let me draw otherwise here, okay, this is your block sphere. So here at the top, this is your Z basis, where your 0 and 1 present. Clear? Now after that one, we have this is Y, this is X. Okay? So now this is Y, this is X, and this is like what I told you. This is what? Like a earth. Okay? So earth means it is, you just assume it to be a globe. Okay? It's a 3D sphere. So if I cut down this earth between, that is into 2 equal half with some imaginary line, what this line to be called as? Equator. Equator, okay, that is 0 degree. Okay, so 0 degree we people are calling. So with that 0 degree of here equator, now here this circular basis is formed. Okay, so what initially happens, your vector remains at this position. Clear? When you apply the Hadamard onto the 0, immediately this vector comes down to what? This position. But this would not extend the limit of this circular basis. This may extend. It would be also possible. But right now, if only the Hadamard is applied, your now vector comes down to what? This position. And now from this, it may revolve around this circle, 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 and once this round gets completed, it would again switch back to what? 0. Like this you see. So what is available at z-axis? This is to be called as, in the analogy of our earth sphere, okay, this is to be called as poles. North pole, south pole. Yes or no? So a north pole, up spin is there, south pole, down spin is there, yes or no? Now this is called as this x basis. Here we have one basis state called plus. What to call? Plus. And if you extend in the negative direction, it would become what? Minus. Clear? Similarly, we have imaginary basis again along with that one, that has to be called as plus of I, and this is what to call, this is minus of I. So first you note down, this is what? This is computational basis. This plus and minus states are called as Fourier basis. What to call? Fourier basis, or you may write down it as like Hadamard basis. Okay? So Fourier basis, I am just using this word again to try to understand. Initially we start with the time domain. Okay? Our quantum particle always starts from a time domain. Okay? Now the time domain have to be shifted from time to frequency. Why? Because once you deal with the frequency, you can have the knowledge about the phase. Yes or no? Clear? That is a phase related information you can be able to obtain. So initially your computational basis to be transformed into a Hadamard basis, or you may call it as what? Fourier basis. Okay? So once you turn down your quantum bit into a superposition of a state, it would be there at any point, and there can be infinite number of points. You may observe, yes or no, like the values, like between zeros and ones, infinite values remain always. Yes or no? Clear this point? Okay. And note down, plus I and minus I are the two bases called as circular basis. Okay. This is circular basis. So several different bases are available in order to visualize your quantum bit. Clear? Now here you may understand the thing. Here you may understand the thing. This is the classical bit. Yes? It is written as a scalar quantity like 0, 1, like a simple thing, that is a coin. Yes or no? A coin. That is a coin having two different states, head, tail. Yes or no? So head, tail like this 0, 1 is available. But when we turn that coin into a quantum state, it would become a vector of information. This is cat 0, cat 1. Yes or no? But here, if you observe, one thing, if you observe, I mentioned this 0 plus 1 by root 2 here at the equator side. Yes or no? Yes? It is one of the published paper. Clear? So if this 0 plus 1 by root 2 state is available at the equator, here what I am saying, once you apply this Hadamard, your immediate next state is what? This is x basis. So what does it mean? Either this correct or that correct. Which one is correct? Both of them are correct. You try to understand. Why both of them are correct? What I said. Once you apply Hadamard, it immediately switch back to this position. Yes? And now start rotating. So while rotating, there would be one possible instance when your vector reaches to this equator. Clear or not? So at that time you may say that it's under superposition. Clear my point or not? So anyway, your vector is realizing a superposition. Clear? Is it clear? So now this is the Hadamard and this is probability amplitude. Clear? We take the probability amplitude associated to each quantum bit. Okay? And once you apply the modulus square on that amplitude, that would give you the probability of measuring your answer. Yes or no? Like 0 and 1. Both states are available with the amplitude 1 by root 2. Once you apply this modulus square, why we are taking modulus square? Why the modulus is required? Because of the complex numbers we people are dealing with. Clear or not? Anyways, the amplitude should be positive 1. Yes or no? So now when we apply this modulus square, so you will get the associated probability to measure your answer. Understood or not? So there would be a half chance. 1 by root 2 square means it would be 1 by 2. So there is a half chance to get your quantum state has to be 0 or the quantum state has to be 1. Understood or not? Like a flipping state of a coin. Once you just toss that coin, the coin remains in a flipping state. So once it is realizing a flipping state means what? It's in a superposition of quantum states like head and tail. Directly you may not call like that it is a superposition of quantum state because head and tails are the classical outcomes. Clear my point or not? But once that coin turns down to the ground again and takes its own position, it immediately converts into a classical outcome. Understood my point or not? Okay. So this is an amplitude which remains always associated to each of the possible quantum state. I started with the fact I was asking about the entanglement. You know this is what? A qubit correlation. Clear or not? The quantum entanglement, the qubits are correlated with each other. Understood? So if the qubits are correlated with each other, means once you perform a measurement on a 1 qubit, the instantaneous measurement would get happen on the associated qubit. So I asked you to visualize any circuit what you have learned. Anyone which is who is able to just visualize that circuit? Simple form of entanglement. Achha, let me share you one example, then we proceed. Okay, then we proceed. Just do not be, just please be comfortable. Now, fact is that related to entanglement. If I say that the two quantum entities, like two qubits, are correlated to each other, means they are strongly connected. It means they are strongly connected. If the qubits are strongly connected with each other, means they are correlated with each other. So how can you prove? We people are being a human. Do we have any entanglement? Are we entangled? Yes. I am letting you know about one example. Like whoever is are like-minded. Like in most of the people are the faculty participants. Okay. So I am assuming that most of the people are just married. So the husband-wife, the relationship what we people are dealing with, okay, we are already remaining entangled with each other. Clear my point? Once if someone says this should be done, the other should also say okay, let's do. But in such a relationship, this does not expected. Okay, this does not be expected here. But try to understand, this should happen. We should remain entangled. Otherwise, there is a problem. Understand or not? So, if you do not make an entanglement, so you may face some problems. But you try to understand again. Really, we people are entangled with, not only this is the specific relationship. We people remain entangled with any other people also. Like you and me in this session. What I can just read out few of the expression. We have become entangled each other. What I am letting you know, you are just convinced. This is the example of the entanglement. Are yes or no? If you are not arguing on a fact, clear my point, or if you are just not denying any of the fact, means you are entangled with me. Clear the point or not? What I told, that we should have some visualization about the qubit entanglement. So how do we get that qubit entanglement here? This is only these things to be coded. These things to be coded initially. This is the initial startup of our quantum programming concept. Okay, you try to understand. How do we? This is the Hadamard. Okay. After Hadamard, what we need to pass? Measurement. Yes, here in the completion of this circuit. Okay. So once you measure this information, you will get either 0 or 1 with the probability 1 by 2. Now here, for entanglement, we need what? At least 2 qubits. Yes or no? At least 2 quantum entities should be involved. Clear? So once I am taking this entanglement circuit here, what to apply? First, you take the Hadamard. Followed by what? Followed by you take a control NOT gate and apply it onto the next one. And then you go for measuring. Clear or not? So what does it mean? On a 1 qubit you have applied a Hadamard. You put down that qubit into a superposition of state. Means 0 and 1 are simultaneously occurring. Yes or no? And once in that situation, like 0 plus 1 by root 2, whenever your quantum state realizes this as 1, this to be taken as a control. Yes or no? And immediately the NOT operation to be applied onto the correlated qubit. That is called as target qubit. Understood or not? So like if you initially start with 0, 0, so from by this 0 it becomes what? 0 plus 1 by root 2. So whenever your quantum state remains present in this 1, you apply this NOT operation on the target qubit. So this would become also what? 1. Clear my point? So what does it mean? If your quantum state remains 0, there is no impact on Q1. Clear? So like in a 2 qubit combination, should I write like 0, 0? This is my first qubit which is available in this 0. Clear? And it has no impact on this target qubit. So the target qubit is 0. Now plus when your quantum, that is your control qubit, remains present in quantum state 1, immediately it applies the NOT gate onto the second or the target qubit. So means when your quantum control qubit is available in 1, the second should be flipped. This is my second qubit and it is to be flipped. So once you flip like this, this is 0, 0 plus 1, 1 by root 2. Again, what I wrote down, you just observe. I wrote down 1 by root 2. Again, you try to understand. This was for 1 qubit. Huh? For 1 qubit, again the amplitude was 1 by root 2. Yes. Here, entangled, but the amplitude is again 1 by root 2. But what about the 2 qubit system? If we have a 2 qubit system, so how many possible quantum states we should have? 4. What are the possible states? These are the possible states: 0, 0, 0, 1, 1, 0 and 1, 1. Clear? These are the 4 different possible states. So what are the other states? Here these 2 states like 0, 1, 1, 0 have been completely lost. Why? Because of the entanglement we have made in the circuit. This is this is we usually called as likely mind. Clear or not? If I am saying let's go for movie, so my associated or entangled partner, whoever is there, he is also agreed. Okay, let's go. Huh? If I am saying that okay, not interested, so other one may have the interest, but he or she is now convinced, okay, if my partner is not ready, I am not going. Understood my point or not? Clear? So like this is one of the Bell pair. This is called as what? Bell pair. Bell pair means it's a maximally entangled state over a 2 qubit system. This is the maximal entangled states. Clear? So out of these 4 different possibilities, only these 2 possibilities are remaining in your system. Okay, because if you are associated with these 4 different possibilities, the amplitude associated with each of them would be what? 1 by under root of 4. So 1 by under root 4 would be what? 1 by 2. And 1 by 2 is still an amplitude. It is not a probability. How do we get the probability? Magnitude square. So once you apply that magnitude square, it will become 1 by 4. So there would be a 1 by 4 probability in order to obtain your either of the possible states. Getting my point? But because of the maximally entangled state what we have already made through this circuit, yes, through this circuit, these 2 possibilities have been completely lost. These are not remaining present in the system. Okay. So only 0, 0 and 1, 1 are remaining present. So that is why in order to measure your answer, still the probability should be what? 1 by 2. Clear my point or not? Is it clear? I will let you know, just demonstrate after few slides. This is still an hypothetical assumption, what you are looking here. You people may see that, okay, 0, 0 and 1, 1 by root 2 means only these 2 states can be measured with half probability. Agree or not? You must be agree. Clear? But I will show you the actual instances where irrespective of these 2 states, the other 2 states may also be available in the quantum system, and that would be due to the noise. Have you heard about quantum noise? That is, the noise remains present in a quantum system. So once the noise remains present in the system, it disturbs your quantum system or the quantum states. So your quantum states, if disturbs, means the random arbitrary quantum states would again be measurable. Clear my point? I will let you know. We have the demonstrated program, don't worry. So just before that one, so this is the example of what? Acha, do you need a break? I don't need break actually. So if they need, so we may take. No issue.
Just to not to stop the momentum, maybe after a few minutes.
It's okay, just let me complete. Okay, so this is what? No, actually I am in a bad habit of taking a long length classes up to 8 hours, 10 hours also per day. So, so it's okay, don't worry. So this is only I am warming up here. So this is warm up session. So here, this is 0 plus 1 by root 2. Understood? This is as per the superposition. Now, this is the demonstration. This is one of the qubit which is available in up spinning state. This is down spinning state. Clear? Now, if we have made both of them entangled each other, so either both of them are available in a up spin or both of them available in a down spin. This is known to be a 0, 0 plus 1, 1 by root 2. This is the simple circuit. Clear or no? Yes or no? Now, can you be able to understand this block sphere terms? These are what? Poles. This is equator. Okay? Okay. How do we get the location of a particular object on our earth? It's based on longitude, latitude. Yes or no? Based on longitude, latitude. But only these 2 terms would be changed here in our block sphere model. That would become cos theta, sin theta. That's it. Clear my point? To understand about longitude, latitude. Understood? So the thing is that the quantum system is highly a complex system. And you will be familiar with that system also once you start coding that thing. Okay? So once you start coding, really you would become comfortable with every of the quantum aspects. I am again repeating, every of the quantum aspects. Nothing to be worried more. Okay, initially there would be a problem while learning quantum computing. Okay, I started when there were no such resources, no resource person, even no teacher was available. So, but you try to understand. Nowadays we have no such problem. Clear my point or not? Okay, only try to connect with some analogies. Understood? So you will be able to better develop your conceptualization in terms of quantum computing. That would be good enough. Clear? Okay, so let's have a tea break because let's have a tea break. How much time? 10 minutes only. ठीक है. Okay, please take. This was this part to be discussed. No, it's okay, sir. Thank you. Just please go fast, come fast. Sir, लीजिए. नहीं ठीक है, it's okay. लीजिए लीजिए. नहीं. हाँ अच्छा 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 चलिए थैंक यू. इसको बंद कर दूँ मैं.
Take him for a small cup of coffee.
Yes, sir. anyways we are not Salman Khan. Once we committed, so we cannot turn back. Yes or no? So shall we start? Or wait? Start. Chalo. Now, try to map. This is इसमें कोई लाइट नहीं जलती है क्या? लेजर पेजर ये लाइट का है तो इसमें पूछना. इसमें लेजर नहीं चलेगा क्या? चलेगा, बताना कहाँ है. कहाँ से चलेगा? ऊपर वाले से. ये वाला. हाँ ये है ना, ठीक है. Now, this is actually a classification. You are known. This classification you are also known, I think. If suppose you have gone through some of or few of the quantum machine learning paper, so in most of the paper the people used to make such a diagram. But this is the comparative map I always used to present in front of the participants. Okay, you try to understand. Everything is a mapping here. Okay, so how do we map? This is the Flynn's classification. As per the Flynn's classification based on instruction and a data stream, it has classified, means the Flynn's has classified the 4 different computing architectures. Yes or no? Like SISD, SIMD, MISD, MIMD. SISD is none of use. Yes or no? It's just like a uniprocessor system realizing a pipelining support. This is the lowest level of processing what we discussed in the morning time. Yes or no? The target is what? Vector processing. That is SIMD. Yes. Vector processing, or it is for the parallel processing purpose. But if we talk about MISD, so it is just none of use, only included for the completeness, for the classification schemes. Yes or no? But our ultimate target is what? That is MIMD, multiple processors or multiple computer based systems we are needing. Clear? Now try to map all of them. SISD to be mapped with what? CC. CC stands for a classical type of data that is to be run over the classical algorithm. Do you find any significance on that one? It's a typical classical processing system. Understood or not? So there is no such quantum here. But if we want to involve a quantum, so like this SIMD, this is our first target, na? Yes, do you agree? This is our first target, SIMD. So equivalent to this SIMD, we have CQ. CQ stands for the classically encoded data, means the classical data to be encoded in the quantum form and then to be processed using a quantum algorithm. So whatever the classical data we have, that classical data is initially transformed into a quantum encoding format. Once your quantum data is available, we have to put that data onto the quantum circuit. Clear? That would be called as a feature map. Anyways, the feature would be mapped over the circuit. Now, your quantum circuit equivalent to the quantum algorithm would then be applied onto the quantum data in order to obtain your results. Understood or not? So now, so this is our first target. Here this QC. QC stands for quantum data that is to be processed using a classical one. Still, like in an analogy of this Flynn's classification, like MISD is of no such usage, okay, but included for what? Completeness. So still this QC is included for completeness purpose. Understood or not? Another thing is that this is my ultimate target. We people are looking for a quantum machine that is enough capable of processing the data in quantum, means everything, like we usually, whatever the data set we have, the data sets are available in classical format, but we people are expecting that my data set should be available in quantum format. Yes or no? Like Panelline, if you are known for, Panelline is one of the dedicated software framework, okay, for quantum machine learning. The people have formed few of the data sets dedicated towards the quantum processing. So they people are simply approaching towards this field like QQ, okay, like inherently quantum system, means the data should be available in a quantum form and the processing of that data should be available on the quantum machine. Is it clear? Okay. So this is we people are expecting, these two, only these two, like here, these two was expected in a classical machine. Is this clear? Okay. So this is just a mapping that why we people are seeking for a parallelization in a quantum machine. Understood? Now this is all related to what or why we people are interested in quantum computing, that is the quantum bits which are realizing a superposition, entanglement, parallelism by default, exponential number of operations which are getting executed in a single step of execution or a single step of time. It is an example of what? Parallelism. We have already discussed about the quantum parallelism while accessing the RAM, while solving what? 0-1 knapsack problem, that is a Boolean knapsack problem. Yes or no? While solving the dimensionality reductions. Okay, we have taken these n number of examples based on what? Our quantum parallelism system. And this is all about your quantum sphere. This is how only your quantum that is qubit starts moving. Okay, I'll show you everything, what happens with your system. Now, quantum coherence and interference. Coherence means stability. That is qubit stability. Means the quantum bit is available in a quantum state form. Yes or no? So the longer coherence time we always expect. Clear? So if you are saying that my superposition is under realization means your vector is moving like this. It means what? Your coherence is still available. Your quantum system is realizing that superposition. But once this coherence is lost, your quantum state of information immediately turns down to a classical state of information. Clear my point or not? Yes or no? Huh? So what does it mean? Okay, once you perform one transition, only one transition over a quantum system, that would lead you to the classical system. So what that transition to be called? That transition is basically called as decoherence. If you see here, this one, it's a transition. Yes or no? Before that transition, it was what? Superposition of head and tail. But once you perform this decoherence, so this decoherence means the coherence of quantum states have been lost. Clear? Now this decoherence transition is leading either to head or to tail. Understand or not? Now you try to understand, you people have to note down. Decoherence can be appeared in two ways. First, intentional. We people are interested to have the decoherence, that is called as measurement. We apply quantum measurement such that the quantum state should be lost and we are expecting some classical outcomes. Clear my point? This is intentional. Second is unintentional, and this is due to noise. If the noise remains present in the system, so at arbitrary random, any of the quantum state can get measured. Understood or not? Immediately the quantum state of the system would get lost and one of the classical outcome at arbitrary random output would be available to your outcome. Understood or not? I will demonstrate, don't worry. Just after few slides we have the demonstrated that is snapshots of the IBM quantum, because simulator or the simulation what we will be doing simulation would be exact. You try to understand. Whatever the ideal system we people are expecting, the same ideal system will be simulated, like a quantum behavior. Okay, there is no such noise, but we have the noise that can be included in our quantum code. We have the privilege. Okay, but when you run the same code onto the machine, so the dedicated or the physical quantum machine will have the noise. Clear my point? And due to noise, the unintentional results will also be measured. Clear my point? Huh? So I'll demonstrate you. Don't worry. So now these are just a pattern of interference. Okay, because this is a phenomena of our quantum system anyways. Okay, this leads the constructive destructive interference patterns. Our quantum states overlaps each other. Yes or no? When our quantum states overlap each other, then only it is supporting what? The quantum parallelism. And whatever the desired results are there, their corresponding amplitudes would become high, like this. This is in wave. Yes or no? So like this waveform and this waveform, both are likely to each other. So their corresponding waveforms would be added together in order to amplify that signal. Understood or not? However, these two waveforms, if you closely observe, they both are opposite to each other. So they will cancel out each other. Clear my point? And after cancelling it out, there would be no possibility of what? Amplitude. Like an ECG line. If a person dead, clear my point or not? Huh? If alive, means it's going on. It is not like a ECG pattern. It is a PQRST waveform. It is a simple sine waveform. Clear my point or not? But try to understand. So our quantum system is highly comprising of these interference patterns. Always. So these patterns would always be there, and based upon the likeliness of the observables, what we are interested to observe from the system, because the system is comprising of all different possibilities. Getting my point? Like for knapsack problem. Okay, like for knapsack problem, 8 different solutions may be available in our quantum system, but out of 8, what we people will be intended for? To get the optimal solution. So whichever the optimal solution path would be there, we will just go through that path. Understood that point? Okay. So now, and this another thing is the quantum circuit and the algorithms. They are, or they must be equivalent to each other anyways. And we should propose both of them in order to have a support to our solutions. That is a quantum based solutions. Clear? Now these are some understanding. Already the things I have discussed, so many things I have discussed, these are only the recall. What are the advantages related to the quantum computing? High speed of computation. Do we have the support now? Exponential number of operations realized in parallel. High speed of computation. It is suitable for compute intensive and expensive jobs. Intensive and expensive means intensive, a problem which is computationally hard. Clear? Expensive, the problem is not computationally hard, rather the data which is involved in the processing of that problem is at least exponentially increased. Clear or not? Means the data which is involving to solve the problem is an exponentially scaled data. So for that data, like a big data processing, okay, so for such data-based processing, still the time we have to spend over our algorithm would be exponential. But this is an expensive operations. Clear my point or not? Now, the thing is time complexity reductions. This is at all the expectation from our side. Yes or no? Because only the machine we people are looking here, that is giving us the privilege for intrinsic parallelism. So because of the intrinsic parallelism what we people are looking here, the time complexity reductions will always be there. Yes or no? Every time the time would be reduced. These are some examples of time complexity reductions, like a RAM. A RAM, that is order of 2 raised to the power 1, but it can be accessed directly in order of 1 time. Means at a single step of execution your entire RAM is open. But anyways, in order to report your answer, okay, this should be what? Order of n is basically the number of qubit involved. But the operation required in order to access your quantum information from the quantum RAM is log of n. You may note down. Okay, I forgot it to write down. Order of n is the number of qubits involved. Okay, but order of log n should be the complexity involved in order to measure your answer from the quantum RAM. Clear? Now, this is another fact, the traveling salesman person problem. It's an intensive problem, computationally hard, but this can be solvable here with the root n factors. Okay, why this root n is available? Because of one dedicated algorithm, what we will be learning in the next session, called as Grover's search algorithm. So Grover search is basically a unstructured database search algorithm. Okay, so unstructured database, we people may expect, like suppose you have a biological sequence of very large in size, terabytes, thousands of terabytes of data, if suppose we have, okay, and over that terabytes of, thousands of terabytes of data, if somebody asks us to find out a particular DNA pattern, still, if you are only looking for an element into a n elements array, the problem can have the solution in a classical domain with the form of linear searching. Linearly come down and check for each position. Yes or no? No better than linear search solution we have in a classical computing. Yes or no? Because the data is unstructured at all. If it would have been the structured data, so there was no problem, we could be able to apply the binary search also. Yes or no? But the data is unstructured, that is why the best known classical solution available to us is only the linear search. But that problem can be solved here using a unstructured search problem in what? Order of root n factor. Still, this is not the concern because n is polynomial value. Understood or not? We are not concerned with the polynomials. But when this n tends to be an exponentially large, then the data involved in such a processing of the problem would be increasing the complexity of our problem. Understood? That is to be categorized as computationally expensive problem. Clear my point or not? So because of such expensiveness available in our data related processing, we still seek for what? The efficient processing methods. And the Grover search would again be one of the possible method for the efficient searching mechanism through the quantum methods. Clear? Now, another would be, let me come up with you, that is integer factorization problem like RSA crypto system. This is not only the new problem now, okay. So RSA crypto system, what we used to call that, okay, our entire crypto system is still believed to be safe, secure, clear. But in 1994 itself, the Peter Shor have given up the quantum algorithm to factorize such a number in a logarithmic time only. Understood? What I am talking about in 94. But still, after 30 years of time, we people are safe. Why? Because we have no such powerful quantum computer till date that can be able to break such a code. But we have the algorithm. Once we have the enough capable quantum machine that can be able to break our quantum system. That is why we people, for us, I think this may be the new thing that, okay, our classical crypto system is still not safe. But NIST, if you know that from US, they have done with the other standards which are safer than the quantum attacks. The people have come up with the cryptographic ciphers, if you know, that is Crystal Kyber, one of the famous cipher, the people have designed, that is for confidentiality purpose. For authentic mechanism, the people have come up with dilithium, crystal dilithium. The people have developed, and the people are transforming their US network with these cryptographic certificates. Okay, so they are transiting from the RSA to the other ciphers. Why? Because they have adopted, they have accepted this fact that once we have a quantum machine which is enough capable of processing such a that is block of code, so that would definitely break our classical crypto system. So under such a scenario, our email, password, etc., everything, internet banking, they would all be completely lost. Clear? No such security would be available to us. Clear? So, like in such a manner, what letting you know that is integer factorization problem can be again solved in a logarithmic time. PCA, we already discussed, where the time was order of n cube, still the interest is not n cube, because it's a cubic polynomial time complexity problem. But if this n tends to be an exponential scaled up, so at that instance, that problem can be solved in order of log n using quantum. Clear? So, by default, our expectation is what? To obtain the exponential speed ups. That is, the thing is that we have the enough computational capabilities of machine, like quantum machine. That machine can give us the factor of what? Time complexity reductions. So once the complexities would be reduced, so by default we are expecting that is getting the speed ups from the machine. Clear my point? Now another is it can handle high dimensional data. I have discussed with one of the instance related to the principal component analysis. Yes or no? Where we have exponentially large number of dimensions or the features available in the data set, and how that data set can be efficiently processed at all. Clear? Next is it solves the complex problem for which the classical supercomputer is still efficient. This is in the context of this factorization problem. Understood? What I am saying, that the classical supercomputers would still take 6 months or 1 year of time in order to break our code. Clear? But if we have the enough powerful quantum machine, so the code can be broken at a single instance. Are yes or no? Clear? So such things are always remaining in our mind to understand the significance of the quantum computing. Now the next is IBM Qiskit framework. Try to understand, this is important because our session is devoted to our programming framework. So let's proceed with our framework now. So first of all, why we people are looking here, that is open source, popular programming framework. This is the first thing. Open source means so everybody will prefer. Clear? And there is no hurdle in order to deal with the Qiskit. And I will let you know. Very simple thing. Developed by IBM for the real world quantum applications, understood, provides the direct access to the dedicated IBM quantum processors. Now you try to understand. We people deal with the cloud technology. One analogy I am again giving you. Okay, we deal with the cloud technology. What are the expected services? Infrastructure as service, yes. Platform as a service, software as a service. These three are the requisite things, okay, for every cloud computing services. Now I am calling one name, quantum computing as a service. So under a quantum computing as a service, we are taking all of them together. All of them together. We are collectively taking what? The IBM cloud platform. Okay, that is as a platform as a service. We are also taking some software packages which are available at the cloud platform as a software as a service. Okay, and infrastructure like a dedicated quantum computer we are going to access in this session only. That would give us the flexibility of what? Infrastructure as a service. Clear? So now try to understand. We people are here intended intended to deal with or to come up with the quantum computing as a service requirements. Okay. Now, thing is easy to use, available with the Python interface. Okay, because everyone is familiar with the Python, and if you are not familiar with Python also, so just you need not to be worried at all, if only you know the concept related to the object oriented programming, and there is no such things that is to be stored in your mind in a bulk related to the object oriented. Simple concept is objects, classes. Understood or not? We have to think upon objects, classes. If you know about the terminologies, you will be able to understand the codes which can be written in Qiskit. So Qiskit is basically a Python based framework, open source code. Clear? Now, the thing is high performance simulators available with the backend. So like a real hardware we can access. So we can have a high performing simulator also. That name of the simulator is Air Simulator. So I will demonstrate all of the that is requisite code through this one of the powerful quantum computing simulator. But it would run your code in the local machine. Understood or not? Means your local machine is a classical machine, like my laptop is a classical machine. Clear? So in our classical machine, this simulator would give us what? The quantum environment. Clear? So under that quantum environment or quantum states would be processed. Understood? Is it clear? So now another is the access to the real quantum hardware or machine through the IBM Quantum, and it is also giving us the support for implementing the quantum algorithms. So the direct support to implement the quantum algorithm is also provided, like the Cover's algorithm, Shor's algorithm, lot of the things, like you people have learned about teleportation, you done. Quantum teleportation, done. चलो कोई बात नहीं, we will cover, let it be, है ना? But this is still a requisite to understand. Okay, these are simple things to understand first. Okay, and whatever the codes are there, you may also realize that while coding through the Qiskit, it would again be one of the challenging tasks. I'll give you some drag and drop play boxes. Okay, some tools, other tools I would also recommend you. Okay, so over that one you start playing with the quantum computing. Okay, so you will have a good visualization as well as good experience to deal with them. You note down one more simulator. This is named as Quirk, Q-U-I-R-K, Quirk, Q-U-I-R-K. It's a component based simulator. I'll let you know. Very simple and easy to understand. Now this is understanding the programming development. This is about the programming development. This is the graph if you visualize. Okay. Before that one, you just look at the names: IBM, D-Wave, Google, Microsoft, Rigetti. These are some strong competitors of developing the quantum machine. But fortunately, you people will. Have you heard about this D-Wave systems? Huh? A dedicated company. The people have started their work for the quantum computer development from 2008. And in a private mission mode like thing, in a secret mission, the people were working for the development of quantum machine. And if you see the growth of that D-Wave system, look at here, how many qubits the people have done. Number of qubits they have realized, 5,000 qubits. And up to what? This is the graph related to that is what? D-Wave. If you see, the graph is about 2024. So up to 2024, and at the start of the 24 itself, they have come up with what? 5,000 qubits of machine. And they all other competitors like IBM, Google, Rigetti, Microsoft, they all are lagging behind. So why only we people are approaching to IBM Quantum? This I am giving you one of the explanation about that one. D-Wave is not commercializing their access of the machines. Getting my point? However, the IBM people have given us the privilege, okay, as in the form of open access. Oh, sorry, that is open source. Clear? So, because of the IBM people have already given us the privilege to access our machine, you may note down, direct or the physical access of the quantum machine is possible with the free access option. So that free access option is available for you for 10 minutes of time. Okay. So 10 minutes of time, there would be a counter for every month. It would be reset, yes or no. And for 10 minutes of time, you may realize your own experiments on the machine. We have n number of backends, but out of all the available backends, few of the backends will be available to you for the free subscription. Because of the free subscription, because if you look for getting the subscription, so it would cost you around 6 lakh, 7 lakh rupees per hour. Okay. So there would be a problem again. Like one recently named company located at Bangalore, QPI, if you heard about, okay. Under National Quantum Mission, the people have got the funding amount, and with that funding amount, they people have come up with 25 qubits of quantum machine. 25 qubits of quantum machine. If you compare 25, there is only this Microsoft, which is very lagging behind, but it is almost about the last year of data. This must be updated again. Getting my point? I am just letting you know about the relative growth of the other competitors. Okay, why only the Qiskit programming framework is that is popular. Clear? So the QPI AI. So QPI AI company has developed a 25 qubits of machine, and how much they are charging? 1 qubit for 1 crore rupee. Means if suppose you ask for the quotation that we people want to have a quantum computer in our university, and if you ask for the quote like for 8 qubit system, so the people will let you know, okay, 8 crore rupees plus 18% GST. Okay, so around 10 crore rupees of funding amount you need to have first in order to spend over a procurement of quantum machine. But it is still none of use, because with 8 qubits, what would you do? Nothing. Clear or not? Because we need the enough powerful machine. We need like commercialized machines. Clear or not? That should be available in the market. China has come up with 2 qubits of machine 6 months before. 2 qubits machine they people have developed, quantum machine, and they have commercialized. The cost of the machine as per the China market price is 8 lakh rupees. Okay, that is in our Indian currency form. Around 8 lakh rupees we have to invest for 2 qubits of machine. What we will be doing? 2 qubit means every day you have one game. You have to just prepare this circuit, run this circuit, and visualize by your own. Clear my point? This is the investment of 8 lakh rupees. Because we cannot get the potential of such a machines. So better is what? Better is to have the cloud-based platform access. Understood or not? Because 10 crore rupees we do not have. Not even for the universities also. Even if we do not have any funding amounts, okay, from any other external agencies, so nobody is going to just invest such a 10 crore rupees of funding amount in the procurement of such a machine. Clear my point? So this is still wasted. The machine of 2 qubits we are not interested in. So what to go for? Go for open source, that is a cloud-based platform. And all of the services from the IBM we are about to access. Infrastructure, platform, software, at all. This is to be called as quantum as a service. Understood or not? Okay, so this is we people are interested in, and if you look forward for the relative growth, the IBM people have developed with 256 qubit machine they are also having, but this is 433 and 1121. 1121 of qubits of machine the people have come up with 2024. This is the highest processing machine available with quantum, but with the free subscription. With the free subscription, the people are only giving the access to 127 qubits of machine, and very limited processors are there. Okay, if suppose they have n different backends, so 2, 3, 4 backends they will be showing to you, and they will be a busy processors always. Once you submit your job, it would take a job queuing time. This may happen that your job is remaining in a queue for 10 minutes. And when it switched back, when it switched to the quantum machine, hardly 1 second of time it takes in order to run your circuit. So I will demonstrate, don't worry. Everything we will see. Just have a curiosity in your mind, okay? So then only you will be able to connect. But if you look forward for the relative growth, like Google, they have come up with the one of the that is software programming framework, that is Circuit. But still, the people are very lagging behind with the other commercialized growth of the companies. Understood? But one thing, if you notice, IBM have developed with what? Superconducting qubits. Google is developing what? Superconducting qubit. Rigetti is one of the dedicated company which is working for what? Superconducting qubits. So superconducting qubits, the people are using for the hardware realization of quantum machine. There can be different possibilities. Okay, annealing is one of the method, like ion trapping is one of the method, of photonics may again be one of the method, over which I am also working with ISRO people, because they need the satellite communication. Okay, so the things are completely different, but what I am recommending you now, just you go for accessing the superconducting qubits, okay, that would be fine with your accessible platform at the IBM. Okay, so now let's have another thing, that is what are the challenges. Still we are in the early stages of development, clear? Technical and economical challenges are always remaining in the system, because what I told you, if you run this same circuit on the quantum machine, due to the presence of the noise, there can be a different possible arbitrary results. Okay, so technical challenges for the development of such a machine such that no such noise remains present in a system is still a vision. Understood or not? Okay. Now the thing is, economical challenges are always be there. Nobody wants to invest first. The thing is that the less number of qubits realization. If you observe the last slide, very less number of qubits have been realized. Only except D-Wave, because D-Wave have done. The people are consistently working for their growth of the quantum machine, but no such usage of commercialization. Okay, so they are thinking bigger than bigger. Okay, what they have their own vision, they people only may let us know. Now the thing is, the lack of quantum computing resources. Okay, this is the thing, the lack of quantum computing resources. We do not have the infrastructure, first of all. Second thing, we do not have the skilled people. Understood or not? Earlier, that is before 6 months, before 6 or 8 months, in the September, October last year, the government decided to teach the brilliant minds like students, B.Tech, UG students, PG students, to develop the skill requirement in quantum computing. But they now faced that we have launched quantum technology as one of the UG course in a minor to be included in the curriculum. The people have come up with the solution. Okay, train the young people. But who will train? Who will train? The teachers are not trained. That is again the gap. So after 3-4 months, they again realized, okay, now we have done the mistake. So now let's start what? Training of teachers. So first, to train the teachers, by default the trainers will teach the students. Clear my point? So the thing is that this is a cycle. Okay, we usually called it these lecture sessions as to be expert sessions, expert lectures. I do not assume like this. I am still a beginner, I am still a learner, yes or no? Because every time throughout life we people are learning, yes or no? Till the end of life, okay, we have new experiences, always, clear? So there is no such expert, but we need to call it as an expert lectures, clear or not? Huh? Chalo, now come up with, the thing is that no physical quantum RAM. This is still one area of development, a physical quantum memory to be realized. Okay, if we have a quantum memory that can realize these things, or that can store a quantum state for longer coherence of time, that would again one of the research aspects that can be covered. Clear? Another fact is what? The lot of errors due to the presence of noise. A machine is realizing lot of errors, but for IBM machine these errors are just 0.5 or max to max 1% errors. 99% the machine is giving the accurate results. I will show you with the backends. Okay, with the backends I will show you. Quantum supremacy has not yet been proved. Okay, I already told you, do not assume ever that the quantum machine is a replacement to the classical machine. It would be a good mix of both. Clear or not? Good mix of both. When they both will be collectively taken for a specific task, the performance of the collaborated machine would be good. Clear? Now these are the applications, specific things like the algorithms, complexity, communication, internet design. Okay, everywhere the quantum computing is now applicable. And cryptography, cryptanalysis, okay, because once the cryptanalytic code have been proposed in 1994 by Peter Shor, and so many other cryptanalytic aspects and the algorithms have already been proposed using some toy ciphers. The people have proposed few of the attacks. This attack is also possible through the quantum onto the classical machines. These ciphers are not secure at all. So the people started working for what? For making the quantum resilient ciphers. Means the ciphers which are secure over the quantum attacks. Clear or not? Like quantum machine learning and intelligence, overall these things to be developed. Quantum computing software development, overall the frameworks are being proposed by the different dedicated organization. Image processing, computer vision, you people have done it already yesterday. Okay, so you may try to collect that these are all the futuristic applications, or still a lot of work the people are doing for the quantum computer development. Clear? Now let's go. This is the Qiskit feature. Look at here. The key features of IBM Qiskit programming. Qiskit is modular and open source. So module based codes we are supposed to write. Clear? A specific module we have to write for a specific purpose. Now built on Python, easy to integrate with the classical libraries like NumPy, SciPy, TensorFlow, these all can be directly used. Okay? These are integrated already with the Qiskit framework. Now it provides the flexibility to extend and modify the quantum circuits and algorithms. So once you have tested your algorithm based on suppose a few number of qubits, and if you are done in a correct way, so you may scale up your algorithm, but still remember you are limited with the number of qubits. I will show you on the IBM quantum computer. The people are giving you the access to 127 computer for free subscription. Okay, they are giving, no worries. But when you use more than 5 qubits, the block sphere, representation, state possibilities, these all are disabled. Why? Because? Why? Because? It's a commercial thing, na? Yes or no? Huh? The thing is that the good things should not be made available for free. Okay? So, they people are giving you the chance. Okay, let's realize. For 5 qubits, you are just, okay, my circuit is running well. So, let's go for 10 qubits. Let's go for 20 qubits. You have the flexibility for 127 qubit, but you have no visualization support. For visualization support, you just have a subscription. Clear or not? A subscription means pay 8 lakh rupees for an hour. Okay? But it's okay. 1 hour of subscription would again be enough. For realizing your, and for one that is a paid subscription, you have the access to 1000 qubit of quantum machine also. And for 1000 qubit of machine, you think upon the exponential number of operations, 2 raised to the power 1000. Okay, this much amount of parallelism you can be able to explore. That is the total expansion of your quantum system. Understood? Now, the Qiskit core components that is to be known. Okay, remember these components. The first one is Terra, Qiskit Terra. This is for building and optimizing the quantum circuits. Okay, this is at the back end. The quantum circuits would be built as well as optimized intrinsically. We do not optimize. Okay, but at the back end, the Qiskit also takes care of optimizing the quantum circuits. Clear? So that Qiskit Terra would be used. Now Qiskit Air, I already told you, Air simulator is a popular backend. That is one of the famous backend that gives us the privilege to realize the quantum behavior in our local machines. Clear? So now this for high performance simulation of quantum circuit. So Qiskit Air is required. Another is IBM Quantum. Okay, that is through the runtime executions. So through IBM Quantum runtime execution means what? You are writing your code in your local machine. Okay, now you are interested to execute that code onto the cloud platform. Like you want to execute your code onto the dedicated machine. Written code, what you have written down in your local machine. So for that purpose you need some token, and that token would be available at your login. That would be a unique ID. Okay, so every unique ID would be assigned to a that is in the with the every login credentials. Okay, so that unique ID we have to use while accessing the IBM Quantum runtime, and with the help of that unique ID, our code can be executed directly on the server, quantum server. Clear? Now another is for a machine learning task. For a machine learning specific task, we have the library with the name of Qiskit machine learning. Clear? So that this is not the syntax to code, or this is not the syntax to write down. I will let you know that how to just install that Qiskit machine learning, but try to remember Qiskit machine learning is a specific package. Okay, that is to be installed for building a quantum based machine learning models. So some ready-made models are there. Like if we are talking about a quantum principal component analysis, we have the ready model. Clear or not? It would take the direct encoded data and apply. But still we are limited with what? Scalability issues. Okay, we cannot scale up because the number of qubits usage are limited. Understood? Now this is one of the thing, that is a layer based structure of a Qiskit you try to understand. If we look here from the bottom to top here, okay, like this problem from top to down, if we see that the problem, we have to map that problem, that is the solution to a problem in the form of circuit. Yes or no? I told you, because what we need, quantum algorithm. Algorithm means, okay, steps. You are known with the steps, what to do, what to apply, but in which order and what gates to be applied in order to have the composition of the quantum circuit. Clear? So once you are ready with your quantum circuit. So these circuits would have standard gates, circuit libraries, timings, relays, pulse, control flows, classical parameters and etc. So many things are involved in your quantum circuit. I mean, let's see. Okay, we have reached to our limit. Understood or not? Now it's total. We will be switching down to the coding portion. A theoretical perspective over now. Okay, this is the last thing to be discussed. Now, transpile. Transpile is a dedicated here method. Okay, so transpile is basically used here as in the form of like this pass manager, that is to synthesize and to optimize our code, that is to circuit, whatever the circuit we have, that circuit would be optimized at the back end. Okay, like for Terra is again working at the back end to optimize our circuit. We people are optimizing or not, it doesn't matter, but at the back end the framework is taking care of optimizing our all circuit. Because why the framework is insisting to optimize the circuit? Because framework knows that we have very limited amount of qubits to be realized. Understood or not? Huh? So now, so this transpile would be a method we will be using in our code. Okay, you just note down what this transpile will do. So the transpile will load our quantum circuit object onto the dedicated backend. Transpile, some transpilers would be there. So that transpile would do what? Would load the quantum circuit object onto the quantum backend. Backend means a machine, okay, like a simulator. So the quantum circuit would be loaded onto the simulator. Okay, so for that purpose we will be using transpiler. Okay, so I will let you know when and after your circuit is ready, loaded, ready, so we can have execution of such a circuit. And for that one we have subsampler and estimator. These are working at the back end, but we can code using these things. These sampler and estimators are basically doing for the computation of probability distributions within the quantum system. Because our quantum system is what? It is comprising of number of quantum states, and for every quantum state we have the associated probability distribution. Yes or no? Like this, a quantum state have been expanded with 1 qubit system. Yes or no? And over that 1 qubit system, the probability distribution of both of them is what? 1 by 2. This is not the probability distribution. Oh, sorry. This is the probability distribution because this is the modulus square. Understood or not? So what we are emphasizing, that our quantum system is comprising of all the possible quantum states. Okay, and from all of such a states, the sampler and these estimator would take care of what? For maintaining such a distribution. Like this 1 by root 2. Okay, in terms of probability would be 1 by 2. Directly on IBM quantum when we will go, so directly you will get to know that okay, these 1 by 2 probability is directly showing, directly available. Okay, so these visualization are available. So this is at the back end, like at the synthesis or like a compiler if you remember. Okay, so in a compiler we have the front end, back end. Yes or no? So at the front end what we do? Analysis, lexical, syntactic, semantic, etc. Okay, at the back end, target code generations. Yes or no? So at the target code generation side we have some synthesis here, like Clifford gate, poly operators, unitary gates, whatever the gates we have already designed. Like in quantum, you may be using a direct gate, but when you just look for its implicit functionality of the gate, that would be a complex gate. Clear or not? Means you are using suppose a gate X as to be called as suppose K. K is the name of the gate, example. But that K gate is comprising of suppose X, Y and Z gate. But you are not aware. You are directly using what? K gate. Understood or not? So these have to be taken care by at the synthetic part of the that is framework. Now these function services like these transpiler service, code assistance, these all, because the code assistance would always be there, because if any of the programming mistakes would be there, so the compiler should also let you know also. Okay, these are the target code generations, backends to be for the preparation of your instruction set and to prepare your code that is to be executed locally on your machine. Okay, so these are some related quantum information for visualization purpose and serialization purpose. These all components would be available directly on what? IBM Qiskit. I will let you know directly these quantum informations would be available, visualization would be available, okay, as well as this serialization would be available. The QASM code, that is quantum assembly code, would always be available on the right side of the tab. Once you just drag and drop your quantum gates onto the circuit, right side some code would be automatically written. Understood or not? So now let's proceed with the installation of a Qiskit. So now please start, or if you have or if you need 1 or 2 minutes of switching time, that is for context switching, है ना? That is switching time required maybe for your side, because now from the theoretical perspective we are now moving down to practical environment. So please open your laptops. क्या हो गया मैडम? वाईफाई वर्किंग नहीं भी है तो मोबाइल डेटा तो चल ही जाता है. देख लीजिए. Acha, now what I would recommend you one again, when you proceed with the installation of Qiskit, so by default it would always install the latest package. Understood? At latest we have the Qiskit 2.0. Okay, but remember, because such a library Qiskit has not been standardized till date. You remember what I am just letting you know, the fact, like C programming developed 1972 around, yes or no? But when it got standardized, 90s by NC, now we see that NCC, NCC++, because the standards have been set after 18 years. Clear my point? So with the help of such standards, we are still relying to C programming. Whatever we used to write, these are the standard notations, yes or no? But here in quantum, because the programming framework has not been standardized till date, so many fluctuations, so many shufflings of the packages or the functions, transformations of the functions, the people are continuously doing. If suppose one of the function, dedicated function was there in X package, now in the next version they have migrated from X to Y. Now if you do not know whether the X package, that is the function belongs to X package, have been migrated to Y, so you will start getting the error. Clear? So what I would recommend you, so when you install this Qiskit in your machine, so you write down pip install Qiskit and put equal operator. What operator? Equal. Equal and assignment both are different. Yes? When we write X or Z assigns the value like this, Z assigns the value X plus Y. So this is assignment. I am talking about equal operator. Okay? So the specific version of the Qiskit you try to install. Okay? So you will be able to execute these codes locally at your machine. Okay? So I will share you the code files also, so you would be becoming comfortable to execute the code. Okay? So note down that version is 1.3.0 because it is stable till that 1.3.0. But they people have come up. If you do not write, means it would by default install the latest version. Latest version means again lot of things to deal with. Clear? So just do not rely with the latest version. Okay? So what is the first step? You try to understand. Visual Studio Code have already been installed, I think. You must be having in your machine. Okay? This is the first way. You download the Visual Studio Code directly, otherwise you write down on Google Visual Studio Code download. You will get the first link. Download Visual Studio Code. After that one, write down Anaconda download. Okay? Go anacondadownload.com/download. Clear? You will have again the specific download link. Download and install both of them. Clear? After installing both of them, you go to what? Visual Studio Code. Few things are missing. So you go to Visual Studio Code and install the Python extensions. Clear? So whatever the Python extensions are there, you install at the Visual Studio Code first. Clear? Because the Python framework will be provided by Anaconda. Understood or not? So once you have already installed, extensions you have already plugged in, that's it. Okay, your setup would be almost ready with the Python. But now then you have the responsibility to go for Qiskit installation. Then only you may proceed for, that is pip install Qiskit. Acha, it doesn't matter if you have the latest version of Python, because Python is a stable version, no problem. Okay, but Qiskit is not stable. Okay. So are you doing? No problem. If you have directly installed, so there are n number of ways. This is only the first way. But these three things to be installed. Okay, done? PIP, Qiskit version 1.3.0. You Google it first. Okay, 1.3.0. Check for some features available in that version. Okay, it is a stable version. Clear? And put a equal operator. And after that 1.3.0, you write down and start downloading the packages. What's happening? Where is yours? Already Python is installed, na? So it's okay. PIP install Qiskit, you download. But Qiskit equal to version, you put equal to 1.3.0. So you know Python Qiskit version, PIP show Qiskit. You write down, if you need to know about the Qiskit version, so you write down PIP show Qiskit. No, Anaconda. नहीं distribution this. हाँ. एक मिनट कम. हाँ. आप बताओ.
I checked in my prompt. Actually, I installed Python 3.1.
So Qiskit not found na, because you have not installed, I think.
In Visual Studio, I installed.
You install again Qiskit, and if suppose it have been earlier installed, so it would overwrite. It would first uninstall the Qiskit earlier version. Clear?
Python, again, graphical installer command.
Acha, for Mac machine you are using, na?
The graphical is okay.
हाँ, graphical okay. Acha, now look, for fast processing purpose also we have other options. Like, this is the first way. Look at the board. Look at the slide. This is the one way that we should set up locally in our machine. But it is best Because once your setup is ready in your machine means you are comfortable. Clear my, it is handy, clear or not. But once you are dependent means it would be a problem again. But if you go like the quantum environment onto Google Colab, look at here, directly you may also run your code on the Google Colab. So this is the usage of what? Platform as a service now. Yes or no? So the quantum services you may use through the Google Colab platform. So what to do? Go to the Google Colab, open a new notebook and install these same packages. Okay? Huh? No, but listen one more thing. Working on Google Colab means each time you will have to set up this environment, because the backend, the platform independency is there, na? The platform you people are going to use as a service. So every time you have to ready your platform according to your code. Okay? So every time, suppose for running a single circuit of Adamart gate, but if you are using what? These commands to be included at your Google Colab, so it would be again a time consuming task. Takes time. But once your local machine is ready with, so you may run your code directly, no problem. Understood? Let me come back. Is it done? Visual Studio done. How many have done this? Please raise the hands. Please, like this. You can understand my concern. You are the faculty people, na? So you may understand. Because students we do not expect. Now in the today's era, no student want to learn. They are completely relying on that is ChatGPT. ChatGPT चाहिए सब. Done? It's simple. It is a 1 minute of download. Anaconda taking time. Oh. 1.3.0. But put equal operator, then you write down. It would hardly take 10 minutes of time to just configure your machine. Okay. What, sir? Visualization installed. You install Qiskit Air also. Qiskit Air is a backend for air simulator purpose. Okay. Actually, these are minimal packages we people are installing. But this would be fine for running the basic codes as well as some advanced code also. Okay, because this package contains so many things. Okay, so many libraries are coming in default. So installed to done, ready na? So just I am letting you know about the code, hai na? Then you start running. Madam, machine? No laptop. Huh? Will you save the code in WhatsApp? Sure. Whatever the code I will demonstrate, the code files I will share. Hai na? Otherwise, what is the use? There is no movie going on. So this is the first way, and those who are still struggling, suppose, so you may go for that is for developing your platform as through the Google Colab. by running these all three commands. Okay, pip install Qiskit, Qiskit visualization. Visualization should be separately installed, but in our latest packages it has been automatically installed. But it is no problem, there is no problem. If you reinstall it also, so it will let you know that whatever the requirement you are expecting, it has been satisfied, like this. Clear or not? Okay. Now, after that one, the pip install Qiskit. This Qiskit Air, you just look at here. Qiskit Air is a package for quantum simulator. Okay. But here the hyphen is used. But when we import that library, so we will use underscore. So I told standardization of the language has not been done. A lot of things to just remember. Otherwise, you are running a same code, but it would not run. It would give lot of error. Underscore at when we import from Qiskit Air. Import, we will be importing a backend. Backend name is Air Simulator. I'll let you know. Every programming concept I will let you know. Don't worry. Ajoo.
It is installing, sir. How much can I pay for?
2.0. So you will have a problem otherwise.
Sir, by default I click to
So because you did not put equal to 1.3.0.
it is updated version, is it not about?
Updated version, I said already. If you install the updated version, recently updated.
Yeah, 2.0.
So a lot of migration of the APIs also. If you do not know, now becoming a beginner means we have to deal with the stable version of the package.
So that how to, for example,
If you have installed, so you pip uninstall Qiskit. You do uninstall Qiskit.
Qiskit 1.3.0 again.
You put equal operator.
Yes.
After this equal operator, write down 1.3.0. So specifically it will install that particular package.
Visualization when trying to Qiskit installation, it will showing 2.2.0. I'm going for latest version, but it is not downloading, sir. What I can do, sir?
No, you have installed, downloaded these two, na? So you just first install these two.
Yeah, already installed, sir.
Installed, na? So now open Anaconda prompt. Here you write down Anaconda prompt. You open Visual Studio Code. This is Visual Studio. And go to the extensions. Okay, enable all Python extensions. You go to extensions. Here. Here, there. All Python extensions you install. Python, Jupyter. Along with Python extension, you also install Jupyter extension on Visual Studio Code. I will let you know about 3-4 ways. First is through the Visual Studio Code, because the Python extensions will be installed. That is the first thing. Second is through the Jupyter notebook, that is on our local host machine. Clear? Now third, we will be realizing our code onto the Google Colab. That is the third version. Fourth, we will directly drag and drop or design our quantum circuit onto the IBM Quantum and run. That is fourth. Fifth, we will write our code locally and run it onto the quantum machine through the token, through the use of token. So for that one, you need to make an account on IBM Quantum also. We will do everything, don't be worried. And there is no matter of time. If just please be comfortable, है ना? नहीं तो क्या है कि वो गाड़ी निकल जाएगी, फिर नहीं सीख पाएंगे, तो फिर कोई मतलब नहीं. Our demonstration is ready. Next slide. Done? machine? Please bring your machine. Meanwhile, if you code means it's good for you also. Yes? Extensions done?
Done, sir.
Now you go to Anaconda prompt. Anaconda ANA. Where you installed? Not installed. ANA you write down otherwise. Yeah, Anaconda prompt. No. Navigator no. Prompt.
You can go prompt. You can type right now.
Now write down all three commands one by one. But for Qiskit, you write down. You write down here. PIP install. Install. Qiskit. INSTATALL. Qiskit. 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 Equal. Put equal. 1.3.0. 0.0. Put enter. It started collecting packages. Then it would be installed. Now rest of the two you need to install. Okay. Tomorrow I will let you know to install quantum machine learning package. Okay. You first install. Installation done? Sir? Completed? Any problem to anyone? Achha, do you have any WhatsApp group? So let me share you one code for testing purpose, whether the code is running or not. Okay. So madam, I am sharing it with you. Only you download that code, run it locally, check whether your Qiskit is installed, like Hello World program. You do not need to be worried about the meaning of that code. I will let you know what the code it is. Okay, but you first demonstrate by your own whether the superposition is working in your machine or not. है ना? It's an interactive Python notebook file, okay? Madam, please check. Achha, from my side it has not sent. Network problem. Wi-Fi. Received? Chali, good. When I switched on my mobile data, means received. Wi-Fi was taking over. Those who have done with the setup, just please download this file, run locally. Only you double click that file. Okay. There is a single cell and you have to run that cell. Run button is there. Okay. Otherwise press shift enter. By pressing shift enter also your code would run. टाइम कितना है लंच के लिए 1 o'clock लेट हो जाएगा मैडम 12 1 o'clock to 2 o'clock we have to reduce madam means Lunch means, taking lunch means half hour would be sufficient, I think. Huh? Mess little bit far. How far? 10 minutes go, 10 minutes come. 10 minutes eating. Half hour. It's okay. Chalo, done? Last. Code running? Check. Code is running? A circuit drawn, na? Good. You just, okay, let it install. The madam has signaled me. Her code is running. Now, what about you? You just go run all. In your Python environment you set base Python. In Python environment you may use your base Python environment, okay? It would work all, no problem. Run. No, it's okay. It is processing. It's processing. Actually, I have. Actually, मेरी machine में installed है. Otherwise, I would have been demonstrated it to you. But please take it. Huh?
Missing option like that. I installed on Anaconda actually. It is opened by VS Code.
अच्छा, it's already comment, na?
Yes, sir.
What error it is showing?
Option line number 32.
अच्छा, PyLatex library is required. So you install pip install PyLatex enc.
Maybe again.
Pip install PyLatex enc.
Okay, sir.
Okay. Again open Anaconda prompt. है ना? And add.
In Anaconda prompt, I have to install this.
So you install this. Pip install PyLatex enc. That's it. Python latex version है actually, latex version environment है ना? It's running. Sounds great. I'll let you know how to construct. It's a simple mechanism. Qiskit programming is basically simple one. If you just, because it's a Python framework first of all. Second thing is, it is becoming as that is a base programming language, popularly known worldwide. Everybody is using. Okay, so people have already made lot of tools, things to be just interpreted by your own. I'll let you know. Done? So 2 of them of you have already done. Yours done, circuit running. Okay. Those who are realizing a problem related to the PyLatex enc library, you just please install the Python latex enc. Okay, it's running. Okay, sounds great. Sir, where is your machine? No machine. Like I have one quote for the people, like you could not be able to see everywhere in your life like a warrior without a sword, okay, like a barber without a razor, like we should be with our laptops. Okay, हमारी तो यही है ना, हमें इसके अलावा और कुछ है नहीं हमारे पास. 3 people, 4 people done. Just please signal other people also. Already time is going on. Just because of only the non-standardization of the language, na, it creates few problem. Otherwise, no problem. Otherwise, no problem in the entire Qiskit framework. No stable version. Done? How many are remaining? Just please raise your hands. Those who are still trying, just let me know. Those who are not trying, so I am not going to wait for them. Those who are trying, I am with you. No worries. No problem. We may reduce our lunch hour times. चलो यहाँ पे this row complete, this row completed है ना, your row, madam, what's your status? Means program running, not WhatsApp. चलो it's okay, better take seat.
Actually, when I'm trying to install it in Anaconda prompt, it's giving,
No, you opened Anaconda, na?
yes, sir.
So what you are writing? PIP install Qiskit 1. No, equal operator you apply, na? I wrote down there. I distinguished. Assignment and equal operator both are different. No, where na? No, without space, na, madam.
Okay, sir.
इसको तो proceed, yes, no, what has been installed?
They,
What you
I'll try
installed?
again, sir.
Without spaces, you write down. Sir, done? You both machines ready? Sir, a collab so ready always. But every time you will have to, otherwise, है ना, set up your platform. Sir, done? Jupyter, it's okay. Same.
Here we are trying on the Google Colab side.
It's okay.
Yes, we have achieved.
If you, those people who have done on the local machine, you may proceed with Jupyter Notebook. You open Anaconda prompt, write down Jupyter Notebook. Okay, so immediately your Jupyter Notebook would be created. Okay, you open your new notebook, copy and paste the same code, run the same code and visualize what you are getting. What are the results you are getting here? Like quantum states 0 and 1, like histogram plotted. Okay, so if you see that histogram out of 1000 times, how many times 0 got measured, how many times 1 got measured? What happened?
Results not showing.
Run fast. Qiskit Air you I think forgot to install, na sir? So why it is saying no module name Qiskit Air? है ना? You have not installed Qiskit Air. You check, open Anaconda prompt again. है ना? Install Qiskit, install Qiskit Air. Sorry. Yes, just please.
Can we run the same code on Visual Studio?
Yes.
After installation of Qiskit and visualization and here also.
You Python extensions have been installed here?
Python extension installed, environment level is not set, right?
No, it's okay. No problem related to environment variables. Okay, it takes directly. है ना? इसको पाइथन लिखना है इसमें. पाइथन सभी आ गए हैं ना. पाइथन का इंस्टॉल्ड है. इंस्टॉल्ड है पाइथन. यू टाइप पाइथन. whatever the extensions you see, na, you install all. Okay, already installed both. You type Jupyter. You install. Sir, done?
Going also. Sir, going.
Huh? So that is the problem, na? Anaconda is giving you the Python framework. So if with the unavailability of the Python framework, how the Qiskit code would run? It's a Qiskit based, that is Python based framework. Qiskit. Good. So what do you observe here? Out of 1024 times I run that program, and 0 as a quantum state you are measuring as how much time? How many times? 513, 511. Okay. Now you run again the same code and check. It's a completely random system. It's a quantum system. Highly probabilistic system. Yes.
Is it right for installing this visualization?
Yes. No problem.
It is showing no matches found. Qiskit visualization.
Spelling is correct. No problem.
And then I am getting errors.
You may need to restart the kernel to use updated package. You first and restart the kernel first. है ना? Where is your laptop? अच्छा तुम्हारा रिकॉर्डिंग चल रही है. By default 0. I told. Apply NOT gate. Applied. I will demonstrate everything. Don't worry. Let me reach to my demonstration. Na. I am now helping the hands to install the machine first. I would not take time. Do not be worried. Done? AC कम हो गया क्या? नहीं पता नहीं शायद AC कम हो गया क्या? पता नहीं शायद. नहीं ठीक है रहना. 25 पे है ना. 21 पे कर दो. 21 20. चलो डन. $400. You run again and again. You just realize the complete. You just realize and understand the complete random quantum system. What does the histogram is meaning to be? Actually, the probability to measure a quantum state as 0 or 1 is what? 1/2. So with half probability, you are running this code for 1024 times. So at each time, the quantum state is getting created. You are measuring that state. So one random outcome out of 0 and 1 is coming to your end with half probability. Yes or no? Similarly, the task would be extended for next 1023 times. Clear? And out of 1024 complete times, if you observe, around 500 values you will be getting for zeros and 1 because they are equally probable event. Yes? There would be sometimes high, low, but you would not get any results like 100 times you are measuring 0, 900 times you are measuring as 1. It would not happen at all. 450, 475, 550, like these values would be ranging because it would be based on the random outputs. Okay. Sometimes it happens due to the intentional measurement. Sometimes it happens in unintentional noise present in the system, but do not be worried, this is simulator. So it is real results. Madam, done? Hua?
We got the output.
Last time na you did?
This is Visual Studio, sir. Colab we did, sir.
Acha, at Colab you did earlier? Ah, no. You Visual Studio installed? At Studio do not install these things. You go to here, you delete all. Okay? Go to here, go to this, write Python. Can I demonstrate otherwise? अच्छा, पर ये मशीन तो रिकॉर्ड कर रही है, उस मशीन में रिकॉर्डिंग चल रही है. हाँ? No, only the packages related to Python, like Python, debugger, all, है ना? Then install Jupyter. Install everything. Computer have enough memory. No, how much? Done? How many people have done? Just please raise your hands. Still waiting? But we are not interested in Jupyter, sir. We need Qiskit to be installed and to run the demo code. Demo code running, na? Yes. Same program. It's okay. No, this is Anaconda, na? You go to file, go to new, notebook. Okay, it would start your local host. Okay, at that local host again you will find same cells. You like this cells are available to you. Okay, Python, which base kernel I think you used? Which, so it's okay. That the same kernel you used na earlier. You select. No, paste your code. No need line by line. Directly you paste. Actually, hello world program is basically required always. That hello world is a signal that I am now in your world. So okay. हुआ मैडम? नहीं C++ की नहीं, सिर्फ पाइथन चाहिए बस. इधर जुपिटर डालो. इधर कंट्रोल है. अच्छा ठीक है. नहीं इधर ये वाला कहाँ गया? ये. No, here itself you write down na. Jupyter. Jupyter. Very slow. Machine slow or net slow? Acha, those who have done on Visual Studio Code, just please check your code with Jupyter Notebook. Check your code on Google Colab. Done? So now those who have done like these, so why to wait? You go directly, write down on the Google search engine, write down IBM Qiskit Composer. Okay? And by writing down IBM Qiskit Composer, you will directly have the first link to open your Composer. Without account also it would work, but you may not be able to run. For running your code, you will have to make an account. Create your account. अच्छा, कंपोजर पे कर रहे हो. It's easy to work on composer actually, but even to know more about the Qiskit, So code is required.
As per our expectation, we get the results because everything is deterministic. Like at the lowest level of processing, if 0 is stored, means 0 is stored. There is no chance of 1. It's a mutual exclusive behavior of the classical. But instead, if we have the quantum machine, so it's a probabilistic machine, not a deterministic one. So in a probabilistic machine, whatever the quantum information we have, for all such relevant quantum information, there would be an exact probability distribution. Understood? A probability distribution may be uniform or it may be non-uniform also. Like uniformity means what? When you applied Hadamard gate onto the zero initialized qubit, so it is assured that your probability amplitude is what? 1 by root 2. Means the associated probability is 1 by 2. This is to be called as uniform distribution of probabilities. This is by default. The system takes off the probability amplitude. But we can manually set the amplitude associated to the quantum state. Okay, like point 4 is the probability assigned to state 0, 0.75 is assigned to suppose quantum state 1. This can also be done. This is usually done at machine learning portion, quantum machine learning. When we have the classical data, that is to be encoded in a quantum format. Okay, so once we go for formatting such a data, we need encode the data in an amplitude itself, in a different format. Well, will let you know the cost. एक वैसे मैडम बात कर रही है. My voice is audible ना? Yes sir. ये चालू करूँ फिर? Hello. Actually I switched it off.
Actually, we have a habit of taking class of 120 students, and usually earlier in NITs, so no mic facilities the people used to provide. So we have made our voice like with enough pitch. So okay, at the last, the student can be able to. Which one? What happened, sir? Which code you are running?
Previously same.
No, where, how you are using, how you are.
Copy pasting and creating on Python files.
Achha, so directly on Python interface you are working, na? Without Anaconda. But installed Qiskit?
Yes.
Qiskit installed?
Qiskit and visualization.
No, it's okay, it's okay.
And also AES. Oh. These are all the commands.
PIP install Qiskit here, it's okay. Qiskit भी हो गया, visualization भी हो गया. Now, where is the code?